Well, hello, everyone. This is Elisa Baum. I'm GridGain Systems Senior Director of Product Marketing. We'll begin in just a moment, but I first would like to conduct a bit of housekeeping. Could you please raise your hand using the hand icon located in the GoToWebinar control panel to let me know if you can hear me okay? Just like to do a quick sound check. Okay, great, I see hands. That's good news. Next, during this webinar, you will be on mute, but should you have any questions during the discussion, please go ahead and enter them in the questions field within the control panel. At the end of the session, we'll take time to answer as many questions as possible. And in addition, I'll make sure that each and every one of you get a link to the recording of the session, as well as the slides within 48 hours. So I'd like to introduce today's speaker. It's Denis Magda. He's GridGain Systems VP of Product Management, and he's also the Apache Ignite PMC Chair. And Denis will be presenting enabling real-time analytics for Hadoop data lakes with GridGain. And with that said, I'll turn the floor over to you, Denis.
Yeah, hello, Alyssa. Hello, everyone. Thanks for inviting me to host this meetup. It's been a while, right, since my last presentation here. And today we are going to cover an interesting topic, and basically we are going to overview a solution for deployments which are already based on Hadoop data lakes or any other data lakes. And the architects of those solutions are looking for the ways how to boost your batch-based processing, your batch-based operations within memory computing technologies. Before we, for sure, like, and it makes sense, before we dive into the details of the solution, let's find out why that solution was developed and introduced, because generally speaking, it's good to start with a problem definition. And generally speaking, the reason why many architects and enterprise companies are looking for the ways how to accelerate or enable memory computing for data lakes is driven by the digital transformation. The digital transformation basically has been challenging many companies for, I think, more than a decade. And generally speaking, even such conservative companies like who work and operate in financial industry started changing their perception of their business. They now look differently at their business. For instance, if you Ralph Hammers, right, the CEO of ING Bank, says the following: he wants ING to become a tech company with a banking license. So just think about this for a second. What has changed in the mind of Ralph, who is the CEO of one of the largest bank in the world, to do it to claim the following? So yes, ING Bank is doing all of the classical services related to the banks, like retail banking, savings account, investment banking, etc., etc. But by some reason, he wants his customers and his investors to see this bank as a tech company that does something for them, like with banking license. And generally speaking, the idea here is pretty simple. If before, let's say, 20 years ago, 30 years ago, all of the customers of ING would usually go to a local branch if they would like to open a savings account or just a credit account or do some operations with their monies, etc., and they would just come to that branch, they would line up waiting for their time to be to work with a representative ING, etc., etc. So usually a number of local branches would define the throughput, right, of the business. But once the web revolution occurred, once every one of us got mobile applications installed on our devices, now like everyone can do any possible operations with their bank accounts online, not even putting their foot in the door of a local branch of ING or any other bank. And that's what dramatically transformed the way how banks and other companies operate in the era of digital transformation. So generally speaking, this digital transformation momentum puts several challenges on existing architectures and infrastructures of our solutions. First of all, 10 or 100 times more queries, transactions, and operations have to be processed. And those operations, as with my previous example, can be driven by devices, right? Mobile phones, tablets, laptops that are connected to the internet. And kind of try to conjure this for one more time. Before, right, 20 or 30 years ago, the only one way for ING customers would be just to go to the local branch and wait for their time to be to work with a local representative. Now, at any given point of time, late night or early morning, we can open our mobile applications and do any operations we'd like with our bank accounts. And that's why the infrastructure of banks have to process tens or hundreds times more queries, right? And absolutely, the volume of the operations is not the only one. It's not the only one problem. As long as all we as bank customers are connected to the internet can generate that many operations, we also generate much more data for the banks to store and process. And finally, companies and businesses like to accelerate and process the operations not only for transactional workloads, but also for analytics. For instance, if to give you another example related to the banking area, let's say that Barclays provides credits and loans to its customers. And I just want to get a loan, right, for a new car. And for instance, I just go to Barclays website online, I apply for a loan, and then Barclays, generally speaking, it can take for Barclays a couple of minutes to give me that loan or to reject it. And again, I don't need to jump on a call, I don't need to talk to a representative, etc. I don't need to go to a local branch. I can do this everything online. And how Barclays is capable of checking everything online and ensuring that I'm credit worthy? Generally speaking, because Barclays can do a lot of analytics almost in real time or almost in near real time, right? Analyzing history of my transactions, my credit history, etc., etc. And banks are also competing for this because Barclays is only one option for me, right? I can go to American Express, I can go to Bank of America, any other banking system. And the one who will give me the loan first, with the best options, would be the one which I will select. And that's the competition, right? And that's the competition which is driven by the digital transformation. So now you, as a bank, as a financial organization, has to become a tech company, which basically has a banking license to operate, to do some services related to that realm. And generally speaking, the bottlenecks, what we see, the bottlenecks, usually architectural bottlenecks, are databases, storages. Relational databases are perfectly well designed for operational workloads, transactional workloads, but they can hardly scale horizontally. NoSQL databases is a quite opposite beast. They can scale out, but they hardly have any transactional consistency capabilities. And Hadoop is perfectly well designed and works for analytics, for batch analytics. But whenever we are doing all of these operations, like hundreds of times more queries, much more data, real-time analytics together with operational workloads, we need to have something else. We need to have another data layer, which is able to unite and merge different data sets and be exposed to the application level as something similar and easy to be used. And in-memory computing here is one of the possible solutions. It's not the only one for sure. You can find something else, but as long as GridGain and Apache Ignite is a memory computing platform product, here as we are going to review this solution as an option. And there is one efficiency in Apache Ignite and GridGain related to its in-memory capabilities. Yes, Ignite and GridGain has its own native persistence, which basically can allow us to remove any other persistent storage and enable that persistence for the sake of data durability. But that's not required, that's optional. And that possibility is crucial for those who are beginning to adopt memory computing for their architecture. For instance, on this slide, you can see that application layer and data layer can stay the same. You can just slide in your Ignite or GridGain cluster in between, introduce it to your architecture, load data into your in-memory cluster, scale it out, tune it, and that's how you can achieve tremendous performance increase, 10 times or 100 times of queries, process much more data by benefiting from the horizontal scalability. And for sure, you can run transactions, etc. And next question, right, I'd like to review, and that's the primary topic of our conversation, is what should we do with data lakes in particular? Because we should not and must not even envision Ignite or GridGain as a silver bullet, right? As the only one storage or platform that is designed and which can handle all of the possible workloads. Because there are good things which are Ignite and GridGain designed for, and there are bad things for which you don't need to use this platform. And when it comes to the data lake acceleration, here is usually you would use the following architecture if you'd like to enable real-time analytics for your already existing data lakes, which are in this example powered by Hadoop. But in your case, that might be another type of storage. So what's the primary idea of this architecture? So let's start from the beginning. Let's say we had our Hadoop cluster. And we already have our applications that are connected to this cluster. This Hadoop cluster might have been developed and introduced to our business a long time ago. We are ETLing a lot of the data sets into it, and we are running overnight batch-like analytics. So usually it might take like minutes, hours, or dozens of seconds to complete some operations. And then at some point of time, okay, we are recalling that the digital transformation is happening, right? Nowadays, one of our business units come and says that, guys, I'd like to accelerate those reports. It's just, it's counter-competitive. It takes us like, one night or like several hours to wait while you generate these reports. Or why we cannot, let's say, issue loans or do some other operations in a matter of minutes. Why do we wait like 4 hours? And that would be like the first business requirement. And we as software architects, we know that generally speaking, yes, Hadoop is a wonderful solution for analytics, but it's not designed for real time, right? Because the business usually, the business units, which are already operating the time of the digital transformation, they will be requesting for milliseconds, seconds response times. And it's truly hard to do this with Hadoop, if impossible. And after that, what can we do? So like how in-memory computing can solve this problem for us as software architects? We can go ahead and deploy GridGain cluster in our architecture. Just introduce it. Deploy it as a separate solution. Don't try, just to go ahead and cache everything you have in Hadoop in your in-memory GridGain or Ignite cluster. It will just doesn't work. GridGain is not an all-app system, at least yet. And what do you need to put into this GridGain cluster? Just talk to your business units. Find out what are those operations which have to be accelerated with your in-memory computing solution. And then go ahead and preload data from your Hadoop cluster or from your other cluster data lake into your GridGain cluster, only a subset of the data which is needed for those operations which must be accelerated. And after that, what happens with your application layer? Now you have in your system 2 different clusters. You have Hadoop, you have GridGain. You can use Hadoop APIs. You will continue using Hadoop APIs. MapReduce, Impala, Hive, whatever, to go and run all of the previous operations and reports that existed before. At the same time, as long as you have GridGain right now, or Ignite, some application logic will be rewritten to GridGain APIs. For instance, instead of Impala or Hive, you can use SQL native APIs of Ignite and GridGain. Instead of MapReduce, you can use our compute grid. The goal here is just to switch to GridGain for those operations which have to be accelerated, like those reports which you'd like to complete in milliseconds rather than in hours or minutes. And why do we have Spark here? The one can ask. Spark is a perfectly well solution for those operations that need to go to both storages. to your historical data lake and to your fast in-memory cluster driven by GridGain. Because with Spark, you can run so-called federated queries. And I will show you a code snippet there, because that API is pretty trivial. Generally speaking, from your application logic, you connect it to both clusters, and whenever you need, let's say, to merge your latest information about my transactions with my credibility history stored in Hadoop, you can just run one operation, and that operation will go and merge data stored in different clusters. And finally, what's available in this architecture is so-called Hadoop connector. That's just Hadoop connector pack or component, special package that was developed by GridGain that can facilitate architects and engineers with this architecture maintenance. For instance, there are some of the tools and logic that will help us to move or load data from Hadoop to GridGain. There is also some logic that helps with data synchronization, and we are going to review this next. But again, here is just to underscore this once again. Don't try to use GridGain or Ignite for everything. GridGain and Ignite is not a replacement of your data lake, data warehouse, or Hadoop. Those are just different technologies. So I would share the following suggestions. Continue using Hadoop as the storage for your old historical data, like weeks, months, and years. When it comes to GridGain, store the operational data, like warm historical data. For instance, transactions which are being executed for different bank accounts, or like the history of transactions or something else for the last 2 or 3 days, etc. The history of that range. Then, if your business operations can it's fine to complete them in seconds, minutes, or hours, just use Hadoop, continue using Hadoop. And Hadoop is perfectly well designed for standard analytical workloads. When it comes to GridGain, here is we're talking about seconds and milliseconds in relation to the real-time analytics. And GridGain is good for operational workloads plus real-time analytics. For instance, if to go back to my example, which I gave at the beginning, like when I'm trying to apply for a loan and I'm just going to a website of a bank and trying to get it, like the bank will be using GridGain to check my latest history of transactions for the last couple of days, and if this information is enough, and also it will be merged with some of the data related to my credit score, etc. With that scenarios, that's how you can accomplish this operation in real time, and that's how Barclays, ING, or any other bank can issue a loan for a customer like me. And Spark can run federated queries across your operational historical data set. Use this as a tool, and keep in mind that this technology is already available and tested for production usage. So now let's quickly jump and overview this solution in more details. That's one of the solutions, right? For sure, the architecture of how you introduce Ignite or GridGain to your data lake ecosystem might be different. It might be, but that's like basically that architecture which we checked on the previous screen is what GridGain is suggesting and implementing with its own customers. That's what we learned, that's what we adopted, and that's like what we definitely know works in production. But again, there might be something else. Okay, and now let's review what are the APIs that are available to application developers if they decide to use or implement an architecture similar to the one we reviewed. And let's start with GridGain APIs. We are going to skip Hadoop APIs as long as everyone, it's assumed that Hadoop is known to the audience of this webinar. So Ignite SQL Queries. Ignite SQL Queries will remind you standard SQL language with no any differences. But only one exception would be here, that this SQL operates at scale across a cluster of machines. From the application standpoint, right here is we have our application. That will be your application code. Application code is connected to the cluster, and application code can run a query like this one. Nothing changes, just JDBC or DBC driver or Java.NET or any other native API, you connect it to the cluster and run this query with joins. What happens next is being done by Ignite and GridGain, by their SQL engine in particular. This query will be distributed across your cluster node, part of this, and as long as the data is evenly distributed with their usage of affinity collocation, each node of your cluster, here we have 2 nodes, will execute this query locally according to the execution plan generated by your operation, and then each node will send back its portion of result set to your application. And the SQL engine of Ignite and GridGain, part of that logic running on your application side, will do this final merge of the result sets and will return this result set back to your application level. That's how it works. Pretty simple, right? And you, as a SQL expert, you can use similar concepts and practices for SQL optimizations, like secondary indexes, primary indexes. You will be able to analyze the execution plans, you will be able to rewrite your queries, but also here is, as a reference for you, one of the key optimization practices for distributed systems like Ignite and GridGain and any other distributed SQL database is affinity collocation. It's when you basically define a special rule relation between your data. Like here is we see that all the Canadian cities are stored on the same machine where the Canada's record is. And that's basically how you can achieve. Whenever you will be creating these tables, whenever you will be creating your cities table, you will add a special key to the create table command, saying that all of the cities that have special ID will go to the specific node, for instance. That's how it works. It's pretty simple. Next, those of us who are running advanced calculations with their data lakes right now, and you can use Spark or you can use Hadoop MapReduce or you can use any other technology. MapReduce or Spark basically exploits this concept of MapReduce paradigm in general. And this MapReduce paradigm defines the workflow this way. Generally speaking, again, here is somewhere to the right, we have our application that generates compute code. Then this compute code can be split into specific tasks, subtasks, and then each subtask can be executed on a specific cluster node, depending on the data locality, or just basically you can broadcast your task so that you can utilize all of the CPUs of your cluster. And the same way this logic works at GridGain and Ignite. It's the same implementation of MapReduce paradigm. In Ignite and GridGain, we call this framework, this component compute grid, which basically takes, you can write your logic in Java, .NET, and C++, and this logic will be executed on the cluster end. And based on our knowledge, right, and experience of MapReduce and Spark execution engines, we know that the benefit of using MapReduce versus SQL queries, so any other queries that can pull data from the cluster, is that compute logic is executed on the storage end, which avoids or minimizes significantly data movement. And if you don't move data over the network, then you can improve the throughput and performance of your computations dramatically. Finally, some of the customers, we know that they use data lakes for machine learning models, training a lot, and deep learning. And here is, I'm not going to stop for a long time. Just keep in mind that Ignite and GridGain goes with its own implementation for classical machine learning models and algorithms, such as clustering, regressions, decision trees, etc., etc. And this API, as well as SQL and compute grade, are well integrated into the memory architecture of the cluster, which means that if you're going to train K-means clustering model in Ignite and use it later, you can expect that the performance will be really high, as long as this API is designed to work with your Ignite and GridGain clusters. And when it comes to the deep learning, here is we decided not to reinvent the wheel, and generally speaking, you can use TensorFlow as your execution engine and Ignite or GridGain as your storage engine. And Spark, like now we are coming to Spark, and we are going to review GridGain Hadoop connector in more details. But you are able to run federated queries across your Hadoop clusters and GridGain clusters as long as GridGain is integrated with Spark. And you know that Spark natively supports Hadoop deployments. So the idea, sorry, here is pretty simple. Spark for GridGain is just one more API that can use our cluster as a storage. And whenever you will be, if you already have, and that actually simplifies, if you already use Spark in your applications, in your software stack, then migration or usage of Ignite and GridGain will be simplistic for you. So even without any changes, you can just start your cluster, load some data which you need for your operations, and then you can update your Spark-based logic that now, in addition to Hadoop, needs to go to GridGain. And for certainly you'll get performance improvements, because whenever Spark executes data frame or RDDs-based operation, it will know where to take this data from GridGain. And finally, GridGain Hadoop connector, that final component or mediator that can stay in the middle of your GridGain clusters in your data lake and do some useful operations. Let's see like what goes inside right now. And this component was released by GridGain in May. It's available for Enterprise and Ultimate Edition customers. And generally speaking, that's what goes inside right now. But that component is being evolved, and you can expect much more features and capabilities to be added to it later. So generally speaking, the first area this spec will help you with related to data loading. Inside of the pack, you will find a special Spark Loader tool. And this tool, you just run it, and this tool, you supply different parameters related. That's my Hive cluster, that's my GridGain cluster, and that's a list of the tables I'd like to preload from Hadoop and through to GridGain. You supply this information, you start the script, and you will see how your data is transferred from Hadoop to GridGain automatically for you. At the same time, here is, you even do not need to prepare GridGain configuration based on your existing configuration in Hadoop. You can use, if you use Hive for your Hadoop deployments, then you can use GridGain Web Console as it's shown on this screen. You can go to configuration screen, you can connect from that Web Console screen to your existing Hive storage using JDBC driver, and then GridGain Web Console will generate a similar configuration for your GridGain cluster, for those tables, for that data that you'd like to move to GridGain, not the whole data set. So I will discourage you to move the whole data set from Hadoop to GridGain. After that, once the data is loaded, we might need to keep our clusters, Hadoop and GridGain clusters, in sync. And here is, we are suggesting to use Apache Sqoop. That's a pretty good tool. That also, as Ignite belongs to Apache Software Foundation. And generally speaking, it will be doing the following. So if you need to push some of the changes from GridGain synchronously, periodically, or just based on some frequency, then you can use Sqoop for that. Sqoop will connect to GridGain and will accumulate all the changes. It can do even incremental. It can capture even incremental changes, and it will push them back to Hadoop cluster. And the same can be done on an opposite direction. When something is being changed in Hive or Hadoop, and you'd like to push this back to GridGain. That's one of the options. For sure, when it comes to synchronization, there are many more options, but that's basically what goes inside of this pack. Certainly, for instance, we had one of the customers who knows that the changes are coming from a different source, and the application logic updates both Hadoop and GridGain cluster, if both copies have to be stored there. Or let's say the application logic decides and the kind of new information arrived, this information belongs to Hadoop, I'll push it to Hadoop only. Or something new is coming, something operational, this data will go to the cluster. Also, GridGain and Ignite goes with so-called cache store implementation, when you can write changes, when GridGain can write changes automatically whenever they are updated. And in this pack, we have so-called Hive cache store. So if you use Hive and you just like GridGain without any Sqoop usage to push the changes whenever the data is updated, you can enable that in your configuration file. And whenever any data set or any record gets updated in GridGain will push it to Hive in background. And for sure, you can decide what exactly you would like to send back to Hadoop. And finally, final topic here is as Federated-Queries. Generally speaking, based on my experience, usually companies and businesses who are enabling this architecture, when Hadoop and GridGain is deployed separately and the application layer knows and decides what cluster to use for what kind of operations. But in my experience, there were several occurrences when companies were requiring, to have that federated capabilities. Yes, they worked hard to separate the data, to separate the responsibility of GridGain and Hadoop, but sometimes still you need to, let's say, merge operational data with month-old data. And the operational data with, let's say, 1 or 2 days old data might stay in GridGain, while this month-old data stays in Hadoop. And for those scenarios, the companies can use federated queries. Like on this screen, from the API standpoint, it's pretty simple. The first line of code shows that Spark connects to an existing Hive table, cities. And then the next 4 lines, that's how Spark configures and defines several options so that it can connect to GridGain. We connect to GridGain, we connect to person table, and we are like to select the following columns like ID, city, ID, etc. And finally, we are doing inner join with Spark Data Frames API. We are joining GridGain data source with Hive data source based on this city ID column. And that's it. So generally speaking, that's it. The digital transformation, as you've seen, challenged a lot of the businesses, right? Today, I was giving banking customers, like banking use cases as an example, but it's not that different for other verticals. Like it can be retail, it can be logistics, transportation, it can be commerce, gaming, etc., etc. Everyone is challenged, and every company is transforming under the pressure of digital transformation. And those companies that already did a great job of accumulating and processing a lot of the data in their data lakes with the usage of Hadoop or any other storage, sure, they also will be changing. They will be adapting to the digital transformation stream. And this architecture, which we reviewed today, which is based on in-memory computing technology like GridGain and Ignite, can be built into your system pretty easily with minimal disruption. But the return can be dramatic. And what you might want to read next, so just go to GridGain Data Lake Acceleration Solution documentation just to read and learn about it in more details. Try to use. And if you need this Hadoop connector pack that basically goes with some tools related to loading, synchronization, then that's where you can get it from. And for sure, now I'm ready to answer on any questions you might have, or you can send the questions to Ignite, GridGain forums, or you can contact GridGain directly if you need our help to embed in-memory computing into your architecture and enable real-time analytics for you. Thank you.
All right, so I've been seeing a couple questions and they're revolving around one major architectural topic, which is when do you, what are your options for choosing architectures depending on what you're trying to accomplish? So some of the questions are around when should I pipeline independently to GridGain and Hadoop? When should I be using GridGain as a source into Hadoop? And then when should I be using Hadoop as a source of the truth? Because a lot of folks have, this is how I'm interpreting the questions, but a lot of people have used Hadoop as their new data lake. They made it their version of the truth. And so now for historical data, you're going to go there first because that's where the cleanest, most complete version is. So based on that, what would your brief recommendations be for those three options, which are basically taking data from Hadoop, pipelining data in parallel like a Lambda architecture, where you have real-time and historical pipelines side by side, versus moving to a complete real-time architecture where you're pipelining and processing from GridGain into Hadoop?
Yeah, thanks for the question. So generally speaking, this architecture, it's designed to be generic. And the whole goal of this architecture is to show that there are several main pieces, like GridGain, Hadoop, Hadoop connector, and your application layer. And then it's up to you to decide what would be the, how, like, let's say, how the data would flow, right? How the data will be the primary source, or it might be even that, let's say, some data sets reside in Hadoop, and Hadoop is used as a primary source, but for other data sets, GridGain might be the true source of information. So you can have that mingled and converged architecture, when both storages even store kind of primary copies of your records. But anyway, so let's start from the if to answer each question. First one, if you pull data like from Hadoop, right, and if Hadoop your primary copy. So here is you can use GridGain again for, if most of your applications still go to Hadoop, then most likely you might need to update your GridGain datasets periodically with some frequency. That can be done. What I've seen that some of the companies can do this once a day, or like once in a couple of days, or like once in an hour. It depends on like how what is a time lag of the data you can allow for your business for the data which sits in GridGain. But it's up to your application can decide how frequently you can update the data in GridGain if they're just being used as a classical cache to boost your operations. The next one is when you have a sort of Lambda architecture, right? You have some real-time streams, the data flows in your GridGain cluster, and also then it's stored in Hadoop. Here is you can use streaming technologies. You can use Spark even streaming. You can use Kafka Confluent. You can use any other streams. So technologies which can capture, receive, digest, enhance your streams of data, do some operations, and then send them to the GridGain and Hadoop. Both GridGain and Hadoop are integrated with major streaming technologies, including Kafka and Spark, etc. It's up to you to build that architecture. No, I don't see any obstacles here. And the final one is when your GridGain cluster is used as a source of truth, right? And most of the data now, like critical data, sits in that cluster, and that data set has to be pushed to Hadoop periodically or like asynchronously, etc. Doesn't matter, with some frequency. Here is again, just recall my last 10 minutes of my conversation. Here is you can use this Hadoop connector, right? First of all, Hadoop connector goes with that synchronization capability synchronization tool like Apache Sqoop. Apache Sqoop can capture changes from GridGain and push them to Hadoop cluster. At the same time, within this Hadoop connector, we provide so-called Hive cache store. That's an integration that automatically pushes all of the updates that happen in GridGain to your Hadoop cluster, and you select what are the tables you'd like to add to this synchronization pipeline. And finally, again, the simplest probably and the classical approach is when your application generally receives data from somewhere, from some other sources, or like when your application just pushes changes to GridGain, updates GridGain, and the same application logic can use Hadoop APIs, to update certain data sets in your Hadoop data lake. Hopefully it answers the questions.
I think so. Thank you, Denis. And that was basically looks like there's one other question here. How does the GridGain integration with Databricks work? Are there any special considerations? I don't know if you talked to Databricks folks before about this. I know I have, so feel free to take a shot, or I can answer it.
Yeah, just Europe. Feel free to answer this question.
Okay, so Databricks, what'll happen with Databricks is you spin it up. It technically gets spun up in a your own VPN environment in the cloud. So in Amazon, so you have the rights to install your own your other software in the VPN environment. In that case, what you do is you would go add in GridGain into your own private cluster. That's technically how it would work. Otherwise, it's exactly like Spark, and the Spark integration works exactly the same way. So you would expose data frames and RDDs to Databricks. Databricks would then if it's using a data frame, we would optimize the Spark SQL under the covers and edit the DAG to do what's basically push down optimization, where we run certain commands in GridGain, but that is transparent to Databricks and Databricks developer. They don't see that. That's all happening under the covers. So it works exactly the same way with Spark. It's just more of an administrative issue where you will need to manage putting GridGain into the VPN, and you decide how you're going to deploy and manage it with Docker and Kubernetes or however else. I hope that answered the question.
Yeah, I think so.
All right. And yes, apparently that did. So with that, Denis, I think those are all the questions.
Thanks a lot, everyone.